Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 11, Section 1, Space Figures and Cross Sections. So we're going to be doing surface area and volume in this chapter, and the first section just starts us out with some vocabulary and this idea of cross sections. So first we have a polyhedron. A polyhedron is a three-dimensional figure whose surfaces are all polygons, and each of those polygons is called a face. We have an edge, which is a segment formed by the intersection of two faces, and a vertex, which is a point where three or more edges intersect. You can also think about them as faces, three or more faces intersect. So we have Euler's formula. Euler's formula says that if we take the number of faces, which we'll call F, and the number of vertices, V, and the number of edges, E, of a polyhedron, they're related by the formula. If we take the faces plus the vertices, we get the edges plus 2. Okay. Now, a lot of times it's hard to remember, is it the edges or the vertices or the faces? I like, if you kind of look at this, it kind of looks like 5. So for me, I remember 5, and then I know the F is first, then the vertices, and then the E. So you just have to remember where the equal sign goes. So the faces plus the vertices equal the edges plus 2. So however you want to remember it. So for this one, they want me to count the faces and the edges, and then they want me to use Euler's formula to find the number of vertices, even though I can probably count them if I want to. Okay, so count the number of faces. It is a hexagon. So the number of faces, we're going to have 1 for the top, 1 for the bottom, so that gives me 2. And then each side is also going to have its own face, so that'll give me 6. So I get 8 faces. And if I want to count the edges, I have, so this is 8 faces. If I want to count the edges, I have 6 on the top and 6 on the bottom. But I also have 6 along the outside, so that's going to give me 18 edges. Which means if I take the faces plus the vertices, I get the edges plus 2. So the faces are 8, and the edges are 18. So I get 8 equals, so I get 8 plus the vertices equal 20, and the vertices equal 12. And if I quickly count, most of us, I think the vertices are easier to find than the edges or the faces. I have, for the vertices, I have 6 on the top, 6 on the bottom, so it gives me 12, and that is correct. Now, on your homework, there's a soccer ball problem that uses this idea that's much more difficult than the problem that we did. So make sure, remind me to talk about that one in class before you do it, because it is a relatively hard problem. Okay. Now, the last thing they have in this section is cross-section. So a cross-section is the intersection of a solid and a plane. So if we take any three-dimensional solid, any polyhedron, cylinder, cone, or anything like that, and we cut it with a plane, what we're going to get is a cross-section. Some of the things they're going to ask you to do is they're going to ask you to, if I do a cross-section in a certain way, what is going to be the shape that's going to be formed of the cross-section? Or they might ask you to draw a plane cutting through a solid that would create a certain cross-section. So create one that creates a equilateral triangle or a hexagon or something like that. So the first type, they draw a solid and they show you the cross-section, and they just want to describe the cross-section. So for this one, if this is a square prism, so we'll assume it's a square prism. If I do the cross-section and it's perpendicular, what I'm going to get is I'm going to get a square. So what I'm saying is if I took a look at if I used the plane to cut the figure and then I pulled it apart, what I would see in the part that was cut is I would see a square. And for this one, I do have to assume that it's a square prism and that the plane is going perpendicular to the sides. So for this one, I'm going to make another assumption. I'm going to assume that this is an equilateral triangle prism. And again, if I cut it perpendicularly, what I'm going to get is an equilateral triangle. The problems they have in the book are a lot easier than the ones we're going to do. You know, we'll talk about things like what happens if you slant the plane as it goes through. So in this case, what you would start getting is an equilateral, or I'm sorry, what you would get is you would get an isosceles triangle as you slanted it more. And for this one, you'd get like a rectangle. So the book kind of does them fairly basic, but we'll get more in depth. Now the last problem, it says, draw and describe a cross-section formed by a vertical plane intersecting the front and right faces of the cube. Okay. So what we want to have is we want a plane to come through this, and we want it to intersect the front and the right. So what's going to happen is in order to intersect the front and the right, it's going to come through like here, and then it's going to create something that looks like that. We could also have it intersect the bottom, but in any case, if we have the plane intersect the front and the right side, it's going to intersect also either the top or the bottom of the cube. So I could draw this in a certain way so that it'd be equilateral triangle. I could also do it in such a way that it'd be an isosceles triangle. But based on the fact that it just has to intersect the front and the side, I know that it's going to be a triangle. And that's all I can say about it. I don't know if it's isosceles or equilateral because they didn't give me enough information. And that's it for today's notes. Thank you for watching. Have a great day.